Hello everyone, thank you for joining today's Advanced Certification Part 1 recording. First off, we want to apologize for the delay of this recording. We know a lot of people were counting on it, and due to some conflicts, we were unable to host it. So what we're doing right now is we're in the recording room, recording this session, just so you can go back and capture it here today. But what this is really around is Advanced Certification Part 1. And if that isn't telling enough, if you went to live training in the Alteryx community, you'll see that that is related to spatial analytics. So let's jump down here to Alteryx Certification Prep Part 1. And you'll see that we are running this prep session throughout the upcoming months here. In fact, just today we also ran the building macros, so these two will be available shortly. But the spatial analytics in Alteryx was one that we've missed, and we're backfilling it to make sure that everyone feels prepared. So that's what we're going to be talking about today is spatial analytics in Alteryx and how you get started and how you be successful on exam day. So let's go ahead and present back into the here. Let's talk about some workflow background, some training. We'll actually jump into the designer. Now, it is important to know that we aren't going to be able to cover everything that you're going to experience on the exam, but we're going to try to push you in the directions that you need to be looking when it comes to exam day. And then finally, after this session, how do you continue to grow in spatial analytics in a way that you can perform when it comes to test day? First of all, one of the things that we always hint at for our core and advanced exams is that the answer is out there. For any of the questions that we give, it's open book by nature. So community.alteryx.com, the whole community is fair game. So if you have a question about something, you could probably type it in and find it along the way. Now, the way these exams are structured is if you ask questions about everything, you'll run out of time. And you won't be able to complete your exam. So use these opportunities sparingly. But we take pride in the fact that when we develop these exams, all the information that people need to be successful is out there. A lot of what our exams test is not only capability inside of Alteryx, but also people's ability to navigate through all of the Alteryx documentation, blogs, ecosystem in general to find the answers that they need. And finally, if you haven't visited any further into the Alteryx Academy, I certainly recommend these interactive lessons. In fact, we have a course on spatial analytics, and we've even had people internally say that just taking that course on interactive lessons around spatial analytics was the difference between passing and not passing. So go ahead and check that out, and it will greatly help you beyond game day. I think one of the things that is of value is that these are really strongly scripted presentations that we really try to hit home pound for pound information in the smallest time possible. Whereas in this one, I have a general flow that I'm going to follow, but I might be omitting some points, whereas some these interactive lessons, we make sure that we hit on all the important pieces. So what are we going to talk about today? What's the use case, and what are we going to use to solve it? We have some stores in our Denver area that have a trade area overlap. And I want to find the trade area overlap if the trade area was 15 miles. And I want to find them whether they're overlapping with my county and what percent they're overlapping with my county. And we'll actually slice that two different ways once we jump into the workflow itself. But what I want to show you next is some of the things that you're going to need to accomplish this. Okay, so here are 6 set of tools that we'll be using from a spatial standpoint to achieve our desired result. One is the spatial info, one is the trade area, polybuild, polysplit. We actually will not be using those in this workflow. It will be in a separate one that I'll upload as a part of this presentation as well that will be available on community. And then spatial matching, which will be a part of this, and spatial processing, which will always be a part of it. Now, I should just pause here and say, as it relates to the certification exam, the advanced one, anything in the spatial category is fair game. Things that I am presenting on today are probably the most important tools that you're going to incur, but by no means is this meant to be a completely comprehensive preparation session. You will certainly come across different tools that you may not have incurred during the exam time. So I would encourage you that to go in here and just play around with them, to read up on them. And the tools that we're going to use today will make you a dangerous spatial analyst. You'll be actually building spatial workflows, but we'll continue to encourage you to kind of explore all the tools out there and what capabilities they bring to your workflow. So I'll make that call out. The second thing that I'm going to say is, of all the sessions that we present on the advanced certification exam, spatial tends to be one of the heavier categories. I'll say people who have knowledge of spatial workflows tend to do better because there's probably more questions around spatial than there are on any other category. Not to say that you won't incur many, but spatial from an automated exam standpoint, it's really easy to test, right? So if we were testing something like the reporting tools, which we do during the exam, it's hard to actually prove your result via multiple choice question, where it could be achieved by building a workflow not using the reporting tools. The nice thing about spatial tools is that you can only achieve spatial results with spatial tools. So that's why there's a lot of items tested. So if you have a spatial background, and I know a lot of people will say this about the advanced certification program, the more knowledge you have of spatial, the better off you're going to be. In fact, if you wanted to weight your studying, I would weight it more in the direction of spatial than I would probably any other category. If I were to weight any other category second to that, I would also put macros in there. So between those two, I think that takes a pretty big piece of the exam that will help you along the way. So what do all of these tools do? We'll give you a brief introduction to each of these tools and what they do. But at the very basis of spatial analytics is there's really a couple different types of spatial objects. There's points, lines, and shapes. Okay, points, lines, and polygons, whichever you want to think of it as. Points are simply, we're very familiar with it. It's a coordinate. So when I try to Google the nearest pizza place, right, usually Google returns a coordinate that says here's exactly where it is. Now when I hit the directions and say navigate to that, what it's going to do is Google traces a line between where I currently am at and then where the pizza place is at. That is a line. It's a spatial line that's denoting where in space I should be going in order to connect the 2 points. And then finally, we have shapes or polygons. And what shapes or polygons represent is an area. So think of a county or a country, right? If I had an object that says, what does the land area of the U.S. look like? You would see a shape that would look like the U.S. And if you aren't familiar with that, it'll become a little bit more clear a little quickly. But we'll start at the very basic level, right? And that's creating points, a coordinate. Now, we know sometimes that your data sets may not always come with a spatial object, which is a spatial data type that Alteryx processes and is really specific to GIS. But if you are provided some sort of coordinates, then you're already most of the way there. What we have is this create points tool that can take coordinates, consume them, and output what we call a spatial object, or something that essentially renders this point onto a map that allows it to be this point to be analyzed in a spatial manner. So we couldn't natively just calculate, or I shouldn't say we couldn't, but not easily calculate the difference between two lats and longs, but as soon as we put it into a spatial object, we just say, what's the distance between the two? And Alteryx outputs the answer to us. So you can see this tool, for lack of a better word, is simply a conversion tool saying, what's your longitude and latitude? And output it as a spatial point. Now, there are different formats that longitudes and latitudes come in, so you can match these up based on your type of logic. More often than not, you're not going to touch these fields are projected as floating points, and honestly, I don't think you really need to worry about it for the context of the advanced exam. Next up, we have the trade area tool. Now, trade area is essentially generating a shape. Let me drag this picture down here. So let's say I am this pizza place and I am serving pizza and I want to know all customers within 5 miles. I can take that single point and blow it out into a radius or a circle. So if I said within 5 miles, I would look 5 miles in any direction. And if I looked at that whole circle of what area my store encompassed, it would be 10 miles across with a 5-mile radius. So all you have to do is choose a single point and choose the value that you want to expand it, right? In this case, we're going to expand it 15 miles. You can also see that you also run in kilometers, and then also we have drive time minutes. Now it is important, we do test on the idea of drive time minutes, but not using drive time minutes itself. So we'll ask questions like, does this tool use drive time data? What tools use drive time data? All of those are fair game, but we will never ask a question that requires people to have the drive time installation to answer the problem. So we do have awareness of it and understanding that it exists, but we won't drive people to actually use that. But if you did have it and you're not aware, you can actually generate a radius saying, how far would it take? What's my radius look like if I were to drive 5 minutes in any direction? And Alteryx would create that for you. So all this is doing is creating that area, or now a shape, a spatial shape for you to process your data on. Some other interesting things about this trade area tool is many people who use it only see the fact that you can put one value, but that couldn't be more wrong. You can actually put multiple values into a trade area tool. So for example, in the last exercise, I think we saw a screenshot of someone using 15. If I had put in 1, 2, 5, where that 15 was, it would actually create a radius for let's say this is a pizza store, it would create a radius for 1 mile, 2 miles, and 5 miles respectively. On top of that, you not only can create multiple radiuses for one point, or radii, I should say, you can also do banded ranges. So what does my store range look like for 1 to 2 miles out? You can see that it's not included 0 to 1, but from 1 to 2, and then from 4 to 5. Okay. So that is some functionality of the trade area tool that often goes overlooked. Now this tool you'll see in the workflow that I'll upload after this session. That will be a part of it. That particular workflow is actually asking, it's kind of a telecom exercise that's saying if I had something broadcasting in this direction, let's say a cell signal, what would the area of coverage be? And for a lot of telecom companies, it looks like a pie wedge, right? That is being broadcast out, but they might only have a point to represent their single site and the direction that this signal is being sent, right? So during that workflow, you'll see what we do is we essentially take a trade area. We first say from this point, how far out can that beam reach? Let's say this is 5 miles. We then subdivide this circle or this trade area down to a multitude of points, and that way we can actually choose the points that we want to represent the band of our pie wedge. So if our broadcast signal was going directly north, we'd probably, click this point. We'd probably select this point and 5 points in either direction to represent the pie wedge of the direction in which the broadcast is going out. So that's what the poly split tool will do is it'll take a shape and split it down either to points, in this case you saw that, regions, or detailed regions. So detailed regions is a popular one because sometimes I have 2 different data sets, one with my shape of my country and one with the shape of waterways or lakes within that country, right? And we say we only want to calculate land, we don't want to include water as part of our country, right? Let's say it's, we want to calculate private land, and a lot of these lakes are not privately owned, for example, depending on your country. You can split that into detailed regions saying, hey, break out the lakes to essentially create holes within your country to say this doesn't count as land that is purchasable in this case. So you can split this out different ways. And again, we're not going to work with this today, but I would highly encourage all those preparing for the exam to play around with different scenarios of what these do and really read about them a little further. Now the inverse tool that we have of that is called the polybuild tool. So this tool will take a series of points and build them up. So in this case we have a sequence polygon. We'll say we have 5 points numbered 1 through 5. We can choose all those points and say group them by this value. In this case we'll just assume we're one object, so there would be no group by. But we will say the source field that we want to group by is by these spatial objects, and the sequence that they're in is 1 through 5, so we'll draw them in that order. Now, how does it actually draw it? So let's actually look at what that polybuild tool does. And again, this won't be inside of our workflow. It will be in the one that I upload if you want to observe that one. But let's say I have 4 different points, and this is my point 1, point 2, point 3, point 4, and I wanted to use this polybuild tool to build a shape. There are a couple different options. The first one that we saw in the last screenshot is that sequence polyline, which will say, I will build the shape in the order that you tell me. And right now I've got the shapes ordered 1, 2, 3, 4. So we'll draw the line like so. And hopefully it ends with point 1 again, so you can close that space. So this one, your data set will have to reflect that as well to get that final closed line on there. But that is one tool method. You can actually see that as a polyline or a polygon. Actually, you can see the polyline didn't close. So it looks like 2 different answers there. And then finally the convex hull, which really says what's the minimum region between all of these points. I would highly recommend, if you're not familiar with convex hull, to spend a little bit of time on that, because we will be asking questions like, here's a region, what does a convex hull look like for this region? The spatial match tool, you can think of this tool as like the join tool for all spatial functions, right? You can connect one data set with another data set and say, hey, do either of these spatial objects match or not match, right? And the way they match can be dictated by this selection here, where the target blank universe, right? And we have a drop down of number of options. So it could be where the target contains the universe, where the target is within the universe, where it intersects with the universe. There's a lot of options here. But if you want to know more, this is straight out of our help menu. Then you can see it there. But these are all the options. You can choose if the target intersects the universe, and this is what it would look like for 2 spatial objects. Target contains the universe, target is within universe, so on and so forth. I don't want to read this off to everybody, but they'll get the idea. Now, my tip to the test takers here is not only understand these as they are today, but the interactions of different types of shapes, right? So we are different types of spatial objects, I should say. So here we see just 2 shapes interacting with each other, but what happens when a line intersects with a universe, right? What if that's our target is actual line and not a hexagon, right? Or a point? What is the actual output of those? And you can use Alteryx just to explore those for yourself. Finally, the spatial process tool. So this is a way of just manipulating objects against each other, right? They could be points, lines, or shapes. Most typically, we see shapes interact with this spatial process tool. And I really like this tool because the icon is really indicative of what it's going to do at the bare minimum. So all this tool does is allows you to select 2 different spatial objects and somehow process them against each other. Do you want to combine them together into one shape? Do you want to cut the first from the second from the first? Create an intersection object or create an inverse object, and you've got this little guide here that'll help you as you toggle through it. But the reality is this is what it really looks like. So let's just say I have 2 squares, 1 and 2. These exist on the exact same row of my data set, and I want to somehow spatially process them. The first thing I could do is combine them, and my output spatial object would look like this. I could cut the first from the second, so you can see my little piece of 2 is actually cut out because there's overlap on it. I could cut the second from the first, so now you can see the overlap of 1 is getting cut out of 2. I could create an intersection object, and I think this one's easier to start at before inverse intersection. So where do they overlap? What does that look like? Just a little square, which would represent this area. And then the inverse intersection, which is basically saying what parts are not intersecting with each other, right? So it would omit this square as a part of that process. Some other tools that are worth looking at is the spatial info, and this is the last tool that we'll talk about before we actually get into the training itself. But the spatial info tool, it essentially says, hey, I have a spatial object, I have a line, I have a point, tell me information about it, right? So if I have a centroid, or my long and lat that has been converted to a spatial point, and I want to convert it to an x and y, this would be my inverse. I could say, what's my centroid as x and y fields, right? Or as a spatial object, or what is the area of this particular object that I've created so far. So for many of you, if you're taking the advanced exam, hopefully a lot of these tools aren't a surprise to you. If these are, that's not a bad thing. I would just recommend spending a little bit more time on them, and we have designated interactive lessons to make sure that you can understand these tools and processes at a deeper depth. But let's just jump into the designer itself and just start talking about working with spatial objects. So I'm going to open a blank presentation here, and the first thing that I'm going to do is I'm going to drag on the two files that I'm going to be working with here today. One is this stores yxdb, and the other is this polygons yxdb. Let's take a look at our data and understand what's going on here. First of all, I have stores, and let's say I'm Miller Industries, and I have 10 different stores, and I want to understand something about them. So I can see I have 10 stores. They're all located at these addresses in the Denver area or surrounding cities in Colorado, and I have latitude and longitude. If I'm already looking at this, I'm already thinking I have lat and long. I really want to be able to convert this to spatial data so I can really understand what where my stores actually exist on a map. The second thing that we have is these county shapes. Okay, so I can see counties around the Denver area, and presumably their zip code or their key number, and then their polygon. Now, this is not very enlightening. It's just the word polygon, and this is the important thing to show you. Now, if I were to run these data sets, you'll see that this sample view of the data isn't really indicative of what's there. So I'm just going to run this and show you at a very high level one of the basic rules of spatial objects within the Alteryx designer. The first rule that you should always be aware of is that in the results window, you'll get this cryptic message saying, hey, there's a polygon here, but you'll need a browse tool to actually see it on a map. In this case, for my lat and long, since they're just numbers not converted to spatial objects yet, they'll just display as numbers. But let's just go ahead and add a browse to this particular tool and run it. And you can see now with my particular, this particular data set, I have a view of all my counties and their shapes. Now, by default, many of you might be having this blank view that I have as well. Just add a little context by going to this base map option and just choose one of the map layers, and then you can render it and see all of the counties underneath it, or sorry, all of the map underneath it, which allows a little bit more context. So, and if I were to click through these, you could actually see, based on the spatial object that I'm clicking, what that really represents. So it's a nice little easy way to navigate through your data itself. Now, the question I have for my store locations today, I actually have two of them. The first of which is, how much does each of my stores overlap with any given county, right? So if I had a store, let's say right here, and expanded 15 miles, and the radius went out to here, I can see it's probably touching this county, this county, this county. What percent of those counties is that trade area in them, right? And then there's probably a large piece in this county, Boulder County right here, that it's overlapping. So what percent for this store am I overlapping into each county? First of all, I need to look at my store data set, and the first thing I need to identify is how do I get my stores to show up on a map? So I'm going to use that create points tool. You can see that it's really, really easy to use. I've got this longitude and latitude selection here, and it usually auto-populates if it fits these two descriptions here, long and lat. If they don't, then you could actually just map them in using this drop-down. So I'm going to add a browse so I can just look at those on top of a map, and I'll choose a layer for that as well, and done. Now, for those of you who say, I don't want to add a map every time I run this workflow, there are options for that. So I'm going to options, edit user settings. I'll let that render here. So let's just tour through here, and this will help you no matter where you go in this advanced exam. You could use this many different ways. There's a lot of things that we test in here, but some of them are these dataset defaults, right? So the first of which is this reference base map. You'll see there's none selected by default, but now anytime I use a browse, if I select some sort of base map, anytime I drop that browse, it will use this Cardo most recent vintage, and I'll select OK. So if I were to bring another browse on here, drop it, and run, you'll see that it has already populated with my most recent vintage. So the good news is that all my stores are on the map. I just want to look at a 15-mile trade area around them. AKA, I want to build a 15-mile radius circle around each of them to understand how far reaching they are. So the tool that we're going to use to accomplish that is called our trade area tool. And you can think of that trade area tool as basically a tool that's really helpful to turn a point into a shape, usually a circle, as people many understand it. So let's take that centroid field, which is the output, it calls it a centroid. We're going to take that point and update it to 15 miles. Now, there is a selection down here that is pretty cool. It allows you to eliminate overlap. So you can see that each of these stores has a wide area of overlap. I could go back here and just say eliminate overlap, and what it will do is just kind of equalize the distance between each of these points to make sure that the overlap doesn't happen. But in this case, I don't care about overlap. What I do care about is just for this store, let's say 109, how much is it overlapping in each county without reducing its overlap with other stores? I'm not really concerned with overlap with other scores right now. Let's go back and view it. Looks like everything is back into its original format. So I'm essentially performing the same task of analysis on 10 stores at a time. What counties does this overlap, and how much of those counties does it overlap? So let's go ahead and say, how do we match up that this store actually touches or intersects or contains any other counties? I'm going to use that spatial match tool, and I purposely just added a bunch of buzzwords that hopefully started getting you in that direction of anytime I want to match these two data sets together, or I always like to say join. It's not exactly a join that's happening here, but relate two data sets together based on their spatial information. Spatial match is the place to go. So let's go in here and select what we want our target and universe to be. At a very high level, I'll say it doesn't matter what you select to be a target in the universe at a high level. If you're in a position where you're actually trying to optimize, the smaller the objects that you have should go into the target, right? So if I have 10 stores at 15 miles radius, that could be a pretty sizable area cumulatively. But over here, I also have a lot of counties, so this actually might be pretty close to even. But if I just had 15 points and all these counties, then the county should definitely go into the universe because that just makes things a little faster to have your larger, more area covered spatial objects going into the universe. But logic-wise, you can pretty much toggle the interaction between target and universe any way that you want them to. So I'm going to go here and say, what do I want from my T target, from my stores, to happen to my universe? So I want to say where the target intersects the universe, right? So where my store intersects with any counties, and I'm going to add some breadth. So I can see my information here. I have my 10 stores with their 15-mile radiuses now, or radii, I should say, and matched them up. So let's see if there's any counties that did not intersect with our store radii. And I'll see that I have no counties. So it looks like they all matched up. So let's take a look at our data set and see what's happening here. So I can see store 100. I'm just going to highlight those. You can see that this store intersected any of these counties. We could go to 101. See which counties it intersects. Let's go select County 109 and look at all of those. So you can see that dynamically it's updating on a per store basis which counties it's touching. Now I just want to see how much of that county, that trade area, is jumping into it. So let's go ahead and do a quick calculation to create what we're going to call an intersection object. Okay, so for this county, I essentially want to say, here's the whole county, and I want to create a little piece of county to calculate the area for. So the area between this county and this trade area. I'm going to use a spatial process tool to cut the data, and I'll say, take our trade area and our county object, right? And I want to create an intersection object. So if my radius overlapped that county, I just want this little piece, aka this little highlighted green, to be my result. So let's go ahead and give that another run and do an inspection on our new intersection object. Okay. Make sure this output correctly. There we go. Okay, so it's highlighting anything within this row right now, so it's difficult to see. Let me just add a select tool just so we can get a better view of what those results look like. So you can see they're just little pieces of overlap between the two, so we can calculate the total of that. Now, I just selected it so we could see it since we had so many overlapping spatial objects, but I'm going to continue down the path here. Now, the thing I want to do is essentially say, what was the county of that, or sorry, what was the area of the county in whole? What's the area of this county object? And what's the area of this object? Because this is essentially represents a fragment of this county. And divide them between the two to create my final calculation of what the percent overlap is. So I'm going to select a spatial info tool and just say for my county object, give me the area in square miles. And I'm going to drop another tool right after and do the same thing for my spatial object that I processed. Let's run that workflow again. If I scroll to the end here, I can see my whole square mileage for my whole county. This county object here is 842 square miles, but the intersection between the trade area and that county only represents 91 square miles. So now I have the two pieces to create my total percent overlap. So let's just clean up some of these fields really quickly here. I'm going to leave the store ID on. I'm going to leave those spatial objects. And I've used all the spatial object information that I need just to derive the area of square miles now. So in essence, I don't really need much in the way of spatial objects anymore, but I'll just keep the points around just in case. I'm going to drop a formula tool on there, and I'm going to call this percent overlap. I'll take the overlap, or the processed square miles, 91.27, and divide it by the whole square mile area of the county itself. And since this is a fraction, I'm just going to multiply that by 100 to get to my final result. So you can see that for this store, it has a 10% overlap into this particular county, a 25% overlap into this next county, and then this county. And I probably should have just kept those county names in. There we go. Just so it was a little easier to understand. So this store overlaps into 5 different counties: Adams, Denver, Jefferson, Arapahoe, and Douglas. And for each of them, it overlaps this amount. Okay. And since there are no counties overlapping with each other, hopefully this doesn't add up into something that's, well, I guess it depends on the county size. I'll redact that statement. It should add up to over 100 depending on the county size. So that is how we arrived on this. Now, let's just say we want to do another set of analyses and essentially calculate what is the total overlap between all of these areas and all of the counties that they touch all at once, right? So really, I just want a small data set that represents what counties are intersected and what percent do we have trade area coverage within those counties. So we'll use the same data set and start building off of that. So what I hope to see out of this is I could see, here's Broomfield County. What percent do we have coverage there? Is it 100% based on trade area? Is it 10%? What counties am I dominating? Which ones do I need to build into? So on and so forth. So what I'm going to do is I'm going to leverage some of the stuff that I've been working on earlier and say we're going to keep the same trade area as always. But this time, I want to combine these trade areas into one massive trade area, right, to represent one giant object. Now, there's a couple ways to do this. What I could do is I could transpose this data and process it. But you'll see this doesn't work very well because I don't have two fields. It's all one field of all my trade areas, and I want to add these up. It would work if they were lined up horizontally. I could add 1 and 2, go in and add another 3 and 4. But I'm going to show something that is going to be pivotal within the exam, is that we actually have tools that also handle spatial functions that aren't in the spatial palette. So here, enter the summarize tool. And for this summarize tool, I want to say, take all of these trade areas, go to my spatial options, and you can see that we have a logic for how we want to process these together. I'm going to say combine them. I'm going to go ahead and add a browse and run. Now I've taken all of my trade areas and combined them into one piece. And so now I'm ready to say, what counties does this intersect with? So let's go back, and this one will be really familiar for most of us because we ran a very similar process up here saying, hey, with this new one very large spatial object, what counties does it intersect with, right? So let's make sure that we've got everything selected. Spatial object, spatial object. Let's run it. And now we can see all the counties it interacts with. But in this case, what I do believe is that we do interact with all counties, so nothing comes out unmatched. So now we could actually start doing some sort of calculation of what percent of this county we overlap with as a whole, right? So in this particular county here, let's see if I can find it. This probably is Denver County. There we go. We'll have pretty much close to 100% overlap in Denver County. In Broomfield, we can expect the answer to be we're 100% covered in Broomfield. But let's go ahead and do that calculation, except this time I'm going to show you an alternate way to get to the solution without using spatial tools because this route will also be tested on the exam, and that's via our formula tools. So any of the information that we've worked with up here, a lot of it can be found within the formula tool. So let's add a column and just calculate what the county square miles are. And I'm going to go to my function selection here, and you'll see that there's many, many spatial functions that we have available to us. In this case, we're going to do exactly what our spatial info was doing, is we'll say, let's get the area of the county object. So I'm going to select area, and spatial object was my county area. Let's make sure that I'm right. Yep. Correct. And then we need to select a unit, which I punched in as square miles. Now, if you didn't know what unit you want to do, it's also square kilometers, but you could always go to the help menu to review that. Let's go to our overlap area, square miles. So let's go to, let's type in overlap square miles. And I'm pretty much just going to copy this one, except just change the variable. Choose this big object here. And then let's do a final one that's percent overlap. So using the information that we have from above, we can say, what's the overlap square miles over the county square miles times 100. And you'll see that this isn't working accurately, so we need to make sure that we change all of our data types before it to double to make sure that it can calculate on those. Okay, we'll make this a double as well. And we'll go ahead and run our workflow. Now you can see that I have some information that doesn't seem to be working out the way I wanted to. So let's go ahead and review what's happening here. What we need to do, and I failed to do in this case, was say what our actual overlap was. I actually just took the area of this particular blob multiple times. So what we'll need to do is actually do something very similar that what we did up here is do a quick spatial process to determine our overlap. Now, what we could do as an alternative, as a nice little workaround that you may not have noticed, is that during our matching process, we can also just match the intersection object between the two options, right? So if I were to go back and select that, instead of matching saying, here's this huge blob and here's this huge county, it would just output the intersection object between the two. And now you can see, I need to make sure that I update my formula. I'm sorry, I need to update the intersection object here. My new percent overlap of the whole data set. And just because I had given you the opportunity, I'm also going to select. So that in all is how I'm going to build it. Now, things that we didn't cover today that are expected, you will be expected to know buffer, distance, generalize. There may or may not be a few on heat map and grid. Those are far less frequent. But everything else outside of those, I'd say, are much, much, much more common. I would recommend getting in here and playing around with all of the different options. The other thing that I'm going to call out is one tool that's really helpful for taking this exam is in the input data category, and it's this map input tool. So while you're preparing for this exam, this is a really great way of kind of creating your own data set to understand how things interact with each other. So let me choose a base map here. You can see that I could draw polygons. So if you wanted to see how two polygons interacted with each other, you could build them both and somehow create them in a way that they intersect with each other. I'll add a browse tool. Just to show you the two shapes that I just drew, I'll add that base map underneath it. And yeah, I could actually play around with those and see how they're actually interacting with each other. Now, for those of you who use this tool quite frequently, there actually is a default that people can use. So every time that I bring this tool into my canvas, and I'm sorry, I'm using a different designer, so the user setting hasn't updated in this one. I could choose the default location in which I want this map input to always land. I can go to Options, User Settings, go to my dataset defaults, and I can set the location. I guess I have to choose the base map first here. So since I'm from the Denver area, I'll just zoom in, square up the frame how I always want it to be applied. Select OK. So the next time I pull in my map input, it's going to square up in the same way that I did it on just now, and I could start drawing shapes over the area that I would want to see the most. So go ahead and play around with it. See what happens when, a shape intersects with a line, or what happens when it contains or doesn't contain. Highly recommend people play around with it. And honestly, that's going to be the way that most people are successful. Now, do note in the exam, there are really two different ways users are going to be tested, one of which is in multiple choice, and the other is going to be in actual practical use cases. So you will not be able to get away with simply just knowing where to click and when to do it. You'll likely have a question that will ask you to solve a problem using spatial tools. And you won't be able to solve it unless you know how to use them cohesively and together. Honestly, once you get to know it, though, it actually becomes pretty easy. So if you want to learn more about it, I'd certainly recommend the spatial course. If you want to know more about spatial objects, I know I breezed through them. You can review them here. We talked a lot about viewing them here today, but how can you calculate distance? How can you relate them to each other? Spatial processing and whatnot, spatially joining data. A lot of great information there, but the best way you're going to learn is over here in the weekly challenge. If I go to this first page in the weekly challenge, index and welcome, here I've got a list of all of our weekly challenges, aka problems that you can try to solve, and anything with the word spatial, try it out. If you're able to master all of these, you'll have no issue working through the problems on exam day. So my recommendation would be to go through and solve any problem that's got the word spatial, and once you do, you'll be set to go. Let's just wrap this now. So I'll get back to my presentation. Again, if you have any more questions, feel free to check out community.alteryx.com. Get friendly with those interactive lessons and weekly challenges. And if you have any more questions on the certification program as a whole, go to certification@alteryx.com and shoot us a note, and we'll respond to you. If you come in any issues with your installation or trying to get Alteryx to work the way you'd expect it to, go ahead and contact support@alteryx.com, and they'll help you out. So I apologize for this being late to being posted, but hopefully you found it helpful, especially since that spatial is going to be a large piece of the advanced exam. But honestly, once people start to learn spatial and work with it, you'll see that there's a weekly challenge group out there of analysts that never see spatial analytics in their regular workday, but they get excited to use all the spatial tools once the exam or the weekly challenge is posted. So that'll be it. If there's any questions, feel free to post them underneath this recording. I'll upload those workflows, and thank you for watching.